could not do with those Luna and those Apollo. So more, better spectrometers, better technology, better wavelength range with which you can take images. So because of the advancement of those technologies, once again this moon missions started. So in 21st century, these are the ones, smart ones. SMART is the acronym for Small Missions for Advanced Research and Technology. European Space Agency. And look at these numbers, 80-meter resolution. So we took images with 80-meter of resolution. So the images are taken from a distance. Then this one, Japanese spacecraft, these two sub-satellites. So they also, it was 2007 and it is still there in space. And in China, 24th of October 2007, and then Chandrayaan 1, India, just now in lunar orbit. Okay. Now, Indian journey towards moon, if we trace back, probably we should start, we should put t equal to 0 in 1963. Okay, 1963 from Kumba, we projected a toy rocket. Okay, toy rocket. The diameter was of 3 inches or so. But then all the electronics needed for projection and this and that was developed for that, and so it started from there. And it took 45 years, and in 45 years India has made, ISRO has made huge advancements, huge advancements. Now in all the departments of this satellite thing, making satellites and spacecrafts, launching, ground control, and then making full use of that, that satellite or spacecraft. In all these departments, they have really made themselves not only self-sufficient, but world leaders. Really world leaders. And the feat which was achieved a few months ago, I believe, 14 satellites launched together. Something great that they can do and successful. This PSLV in a row, 13, this is 14 successful projections in a row without any failure. Whereas if you look at all those Luna and Apollo and that, every third satellite will fail. But ours is always the second satellite, not the third. So those type of expertise ISRO has obtained. Now these are ISRO projected satellites which are still in the space. Some of them are remote sensing satellites. Right? It orbits Earth from a closer distance and then images different minerals and different topography and all those things. And IRS images are respected in the world most because the resolution of IRS means Indian Remote Sensing Satellites. IRS satellites in the world over, people use these images with a great respect that IRS images are the best in the world. So those remote sensing satellites and communication satellites and satellites for particular uses. EduSat is there, for M radios they have a satellite there, for weather they have a satellite there. They have really mastered the technology. Okay? This is Chandrayaan 1, what I say, schematic diagram. Now these are the scientific payloads. There are 11 payload units, 5 completely designed and developed by ISRO or Indian universities in collaboration with ISRO, 3 by European Space Agency, and in these 3, 1 is jointly developed with India, and the other 2 also India has contributed in the putting up electronics and so, 1 by Bulgaria and 2 by NASA, United States. So there are total 11 scientific separate units in that Chandrayaan module, and each has a specific task. The scientific experiment. So this is a terrain mapping camera. So it has, this is a image of Earth, alright, sent by, shot by this TMC camera which is on Chandrayaan 1, and this was shot while it was still orbiting the Earth. It is from a distance of 70,000 kilometers from Earth. So when it was going in one of those elliptical orbits from 70, to test the camera, that the camera is working well, 29th of October. Okay, 29th of October they put the camera on, and the camera sent this picture of Earth. But look at this number. Look at this number. Resolution of 5 meters. I have never seen this. I searched so many, all those lunar prospectors and everything, all those 2000 Japanese moon mission and Chinese moon mission. But the resolution is 5 meters something, which is like 50 centuries of Sachin Tendulkar, nobody can touch. 40 is still Ricky Ponting is at 36. Right? But 5 meter resolution, because everywhere else I find 70 meters of resolution and 40 meters of resolution and at best 25 meters of resolution. But nothing in with that what is called unit place and then decimal unit place. Is that correct? Tens place, right? So nowhere I find 1 or 0 in that tens place, and here it is 0 in the 10th place. So extremely sensitive camera that was designed and put by ISRO as the first payload, and then these other 4 are also developed completely here, right? This is spectroscopic data collection, hyperspectral imager. This will send light with specific wavelengths and then look at the absorption, and from there the elements or the bonds between in the compound those will be identified. Then lunar laser ranging instruments. So this laser 1064 nm. I will not go into high energy X-rays. Uses 20 kV to 250 kV X-rays. Now what are these X-rays doing? These X-rays are going on the elements and they are knocking out the K electrons. And once K electron is knocked out, that K electron falls into K electrons and gives another X-ray photon. And that X-ray has a specific signature of which element it is coming from. Right? So these high energy X-ray spectrometers, they will send X-rays in these energy range, very high energy range in fact for X-ray, and then they will knock out electrons, and then that second generation of X-rays will be detected by the instrument on this particular module, and from there they will know about the uranium, thorium and lead, heavy elements, because heavy elements, the L to K energy is high. So you need large energy to knock out the K electron at first, and then you need those X-rays which are coming from the transition, so you have to detect in that particular range. So this unit is made for that. It will look for heavy elements on the moon's surface. Then this is a moon impact probe. At the first opportunity, that is what they say. Once it is in lunar orbit of that 100 kilometer circle, now it is going in an elliptical orbit. They will fire more orbits to lower down the laser axis, and finally it will go at 100 kilometer circular orbit. And after that, this unit, this 29 kilogram unit, that will separate from the main Chandrayaan 1 and will fall on the surface of the moon. Okay, so that is moon impact probe. So these are the Indian ones, and then these 3 are from European countries. This is X-ray fluorescence spectroscopy. So they have put this 0.5 to 10 kV, and then we look at aluminium, magnesium and titanium basically. Then this is near infrared. So this is also spectroscopy. This is something which will find how the surface changed during the solar wind and other interactions.